Okay, so what did you want to study here?
Like the function itself, like how it turns and retains its shape.
Okay, so what do you want to do? So here we are. I'll go back to the beginning. I'll go to 0. Okay, what do you want? What's the first thing you want to do?
Well, we could rotate it 180 degrees and
But that would just make it pointing down.
Well, let's see what happens. 180 degrees.
we just get that tiny bit.
Hey, what happened? What went wrong?
Well, we just flipped it over.
We just don't have that many negatives.
Okay, so what should we do to display this better?
We could go to 1 to negative.
Yeah.
We could go from -9 to 1.
That would work.
-9 to 1. Okay. So you think this will display better now?
Yeah.
Maybe. And yeah.
Hey.
It's like a reflection of what we had.
Yeah, and so how did you know to go -9 to 1?
Well, because it's the exact, if you looked in a mirror, or if you're looking into a pond and you had this and you had it on one side, you'd just see a mirror image of it.
Huh, interesting. Okay. What do you want to look at now?
We could look at when you rotate it 90 degrees.
Okay, so let's rotate it.
See what we have to adjust the numbers. So here I think we'd have to adjust. We could go back to -1 to 9 on the y-axis.
Well, but then I don't think that would work because.
Well, we can change. We're gonna have to change the x-axis.
Well, but
too.
then look, it just gets that. So maybe we have to go somewhere in the middle.
Maybe -4 to 4 to get it to display
Well, maybe.
evenly.
We could do -5 to 5, because that's the same thing we did with the x-axis.
Okay.
True.
-5 to 5. So that keeps the distance 10.
Yeah.
All right.
Like that.
So it works pretty well.
But then we only see part of it. So maybe we have to change the
Well,
x-axis.
we can't really see all of it.
Yeah.
Yeah, but this is still not what we were seeing before.
Yeah.
When it was at 0.
Well, we
right?
could change the x-axis more. We could change it from. Maybe we
If
could,
we made the 0 where the 4 is now.
so we could change it to minus. Maybe we could change it to -9. So -9 to 1, like we did there. Like that.
Hey,
So it's just like
That looks more like what we
we
saw.
rotated it.
so what happened to our coordinates when we did this?
So I think we swapped the x and y's. The x coordinate became the y coordinate, and the y coordinate became the x coordinate.
That's weird. Why did that happen?
Why did that happen?
Why did that happen?
Well, maybe it has something to do with rotating at 90 degrees.
Okay. What? What happens when you rotate 90 degrees?
Well, it's on its side. So maybe we just rotated the whole thing 90 degrees.
Like the entire graph.
Okay.
90 degrees.
And what's going to happen when you rotate the whole graph
The
90 degrees?
x-axis becomes the y-axis, and the y-axis becomes the x-axis.
Interesting. Except we rotated it this way. We rotated it counterclockwise.
Yeah.
So the y-axis used to be going up like this. So where's the y-axis now?
Would be going over with its eraser pointing this way.
Okay. So did the y-axis become the x-axis?
Yeah. I think it became the negative x-axis.
Yeah. See, we went counterclockwise and it became the negative x-axis. So that's interesting because this is negative in the x direction originally, right? Okay. So let's do one more. So tell me one other rotation you'd like
Well,
to
We
take a
could
look
do 270 degrees.
Yeah.
Oh.
270. Maybe that, because it would rotate clockwise then?
Oh, interesting. Okay, 270. Oops, not 2,700, 270.
And then we just see that tiny bit. We could adjust the.
All right, yeah, let your brother.
So we could adjust the y.
Let your brother. What are we going to adjust the?
So it would have to go from minus. It would have to go from -9 or 9 to -1.
Okay, so I'll put the -1 first
Okay.
to 9. And what about the y-axis?
I think the y-axis can stay the same.
Interesting.
So here the y-axis became the positive x-axis, and the x-axis became the positive y-axis.
You sure?
Well, it rotated clockwise, so this is pointing up. Y became the x, and the x... Did the x become the negative y?
Okay. Why? Well, first of all, we didn't rotate it clockwise by 90 degrees. That's not what we did. What
We
did we
rotated
do?
it counterclockwise by 270 degrees.
Okay. So follow the x-axis and see what happens when you do that rotation.
So you have... This is the regular x-axis. Then 90.
Yeah.
Then this is negative x.
Uh-huh.
So this would be negative y.
Interesting. Now, it looks like the x became the positive y. Why?
Well, because you're rotating at 9... You could think of this as rotating 90 degrees clockwise.
Okay. And what would happen in that situation?
The x would become the positive y.
Show me.
Well, because like if you have this 0.6
Uh-huh.
on the x-axis...
Where does it go?
Well, actually, if you're doing negative 6.
Okay. So why does it look like it's positive rotation when it's really a negative
Well,
rotation?
because the y, like this 0.4 goes to 4 on the x-axis.
Okay. Yeah. So y goes to positive x goes to minus y, but it looks like x went to positive y. So why is it confusing here?
Well, because it's the clockwise and counterclockwise.
Yeah.
I'm not phrasing the question very well. You thought the x became a positive y, right?
Yeah.
Okay, why did you think that?
Well, because I thought the x became a negative y when it rotated 90 degrees.
Okay.
But the x became a y. The x became y when it rotated 90 degrees.
All right.
So, I guess now it becomes negative y.
Okay. What would happen if I switched the positive and negative y's here? So I just did a mirror on the x on what is now the x-axis. What would
Well-
happen to the graph?
Nothing.
Why?
Because this thing is symmetrical,
Uh-huh.
so it would just flip over.
Yeah. So that's why that makes it a little confusing about the positive and negative y's, because it's symmetric about the x-axis now. Anyway, cool. That's neat. So as long as you have the sines and cosines, which comes a little bit later in math, you can start understanding these rotations. But you guys asked some really good questions, so good work today, guys. Good work.